Okay, number 1, this is lesson 6.5 homework. 8 questions, starting with number 1. Factor the following trinomial. When we factor a trinomial, we are looking for the 2 factors. In the future, it might be more than 2 factors, but for now, it's just 2 factors. The 2 binomial factors that multiply together to get the trinomial. How do we break down a trinomial into its factors? How do we take a trinomial and break it down into 2 binomial factors? We did it on Friday. What? There are no like terms. Yeah.
You factor out the x squared, which is x and x.
Good. Let's pause there for a second. She said you factor out the x squared. To get this term, this times this needs to be multiplied together. Well, what do these need to be in order to multiply together to get x squared? X and x. So we've just accomplished half of the problem because x times x is x squared. Now we need a term here. It's going to be plus something or minus something, plus something, minus something. How do we know what the terms are or what the numbers are here? What do we do?
You have to find the numbers that you multiplied by and add.
Yep, multiply to get 42 and add to get 13. If it helps, you can draw your boxes. I make my multiplication boxes nice and long so I can put a couple of pairs in there. 42, that would be 1 and 42 is an option. 2 and 21. 3 is an option. 3 and 14. Is that right? What? We are trying to identify possible factor pairs that multiply together to get 42. You were here on Friday, right? It was the lesson on Friday. Do you remember me drawing these boxes and writing little pairs? So all I'm doing is I'm just listing all of the potential factor pairs that will get you a product of 42. Now, in my head, I'm seeing this 13. I know that whatever the numbers are, they have to add up to 13. So am I really going to use 3 and 14 or whatever that is?
Yes.
No, that's not going to add up to 13. 4, 5, 6, 6 and 7. 6 times 7 is 42. And would you look at that? 6 plus 7 adds up to 13. That's the other thing that you have to test with your numbers. They have to multiply to get 42, your third term. They have to add to get your middle number. Do you remember this?
I remember, I just.
You're like trying to process it all over again? Okay. All of them are like this, so we'll take a little time on this first one. Do you want me to write out steps? Okay.
First, draw your box.
Steps, yeah.
Second.
Hold on. To factor a trinomial where a equals 1. I know you don't understand what that means, but I have to specify that because in the future, you're going to learn how to factor a trinomial, and by the future I mean tomorrow. You're going to learn how to factor a trinomial where this number here, you know how this is an invisible 1 next to this x squared term? This is an invisible 1, okay? You're going to soon learn how to factor trinomials where this invisible 1 isn't a 1. You'll see a number here like 3 or 5 or 2 or 16 or something like that. For now, this term, this coefficient is 1. We call quadratic expressions are simply ax squared plus bx plus c. A, B, and C are simply standing for all of the numbers, all of the coefficients. So this kind of trinomial where x squared does not have any number in front of it is considered a trinomial where a simply equals 1. And is everything okay? What's going on with you, Abby? Okay, get out your notebook and work. To factor a trinomial where a equals 1. Okay, that's why we're going to write it, because tomorrow we're going to do steps for when a doesn't equal 1. To factor a trinomial where a equals 1, you must find the two numbers that multiply to get C and add to get B. Now you need to write down this formula, ax squared plus bx plus c, because b and c stand for those numbers.
I can't see the square.
This?
Yeah.
Did I start the video? Okay. Ax squared plus bx plus c. That is the formula for a quadratic trinomial. Or a quadratic expression. To factor it, when a is 1, or I should say invisible, which means it's 1, all you have to do is find the two numbers that will multiply to get your last number, which we call c, and add to get the middle number, which we call b in the formula. Also known as the last number and the middle number. I'll say before you do that, before all that, first break up the x squared into x and x in the binomials. So that's what we did. So that technically is really the first step, but it's such a simple step, we kind of forget that it is step 1. And we just break up our first term into its factors. To get x squared, we need x times x. And why are they in these spots? Because the FOIL method says that the first terms need to get multiplied to get your first term in your trinomial. That's what the FOIL method tells us. So we put the x here and the x here. Are you good? Okay. Now that we've simply put our x's in their places, we are going to find the two numbers that multiply to get this and add to get this. So you can make, this is the way I do it, it's not the way the book does it, but I find this to be easy. You make two empty boxes to say a number times another number will equal this. Now, usually, your number, your product here, is going to have a couple of different possibilities of factors. 42 has lots of factors. 1 and 42, 2 and 21, 6 and 7, 3 and 14, I believe. Wait, no. Because, yeah, 3 and 14. 3 and 14 would be 1. Out of these pairs, 1 and 42, 2 and 21, 3 and 14, 6 and 7, only one of those pairs can be the correct pair to use in our binomials. How do we choose which pair is correct? They all work to multiply to get 42. How do we choose which pair is correct?
You go to which one equals 13.
Yep. You say which one of these pairs will also add up to get the middle number, 13. Only one of them will work, and it's every time, only one of them will work. So once you decide which of these pairs is the lucky winner, these are the numbers that go as your last terms. Now we're dealing with a positive product and a positive sum, so it's positive, positive. So plus 6 and plus 7, nice and simple. Or you could have x plus 7 first, then x plus 6. They are the same thing, commutative property and multiplication. Now, if you have different numbers, that's good. You need to practice this concept with your numbers.
Do we put the smallest one first?
No, I just said it does not matter which one comes first. Your answer key should mark both of them correct. If it doesn't, it's a glitch and it needs to be fixed. But it should mark either one of them correct. It's a good question though, if you should put the lowest one correct. Are you guys still working on your numbers?
How is there only one pencil left?
Oh, because.
Looks like I have one back to the office.
Are you like hiding pencils so that you can?
No, I'm not. I haven't even been in here yet. But I have, but like, I didn't even enter. I didn't have help. See, I was even here, right?
Do you have backup?
No.
You don't. And there's nobody for you to like bring it to you, right? Is there?
It's okay, I'll calm down.
All right, can I move on?
Mm-hmm.
Same exact steps here. But now one of our numbers is negative, so we're just gonna have to be very careful when we solve this. Again, we have, oh, but look, our first term is y squared. So what would it be here and here? Y. Very good. And then we just need a plus or minus something, plus or minus something. So then we simply, to get these two numbers, we set up boxes. I make them nice and long so I can write pairs. The product needs to be 22. The sum, I make them just regular size boxes for the sum because we're gonna pick from the factor pairs and then put them into these boxes. The sum has to be a negative 13. What's that?
Could it be negative 11
It's a really good question. What I noticed, something that you said a negative number and a positive number. If a negative and a positive multiply together, what kind of number are we gonna get? Negative. And this has to get a positive product. But you're noticing that you're gonna get a negative sum. The only way to get a positive product and a negative sum is to have what? Two negatives. So if both of your factors are negative, when they're multiplied together, they'll cancel out and you'll get a positive. If both of your factors are negative, they'll add together and the answer will be negative. Yep. So negative 11 and negative 2 will multiply together. The other possibilities are a negative 1 and negative 22, but we know that those will not add up to a negative 13, so that will not work. But our negative 11 and our negative 2, they multiply to get positive 22, and they will add to get negative 13. That's it. Something smells like tater tots or something smells good.
Stop laughing at it.
Watch this, watch this. Tater tots.
Drink water and. I have water. Can I go get water?
Yeah, that'd probably be a good idea.
Wash it out. Water.
All right, can I move on? So notice how there's an answer choice here that says the polynomial is prime. Yeah, that would be the only factors would be 1 and itself. So if you're looking at a trinomial and you're like, I cannot get two numbers that multiply to this number and add this number, it's not possible, then your polynomial would be prime. I've actually never seen that in a question, but good to know. Huh? If it's in this, it could be on the EOC. I've just never seen it before, but I'm not allowed to look at EOC questions. So. What? I'm allowed to look at EOC practice questions, but I've never been able to look at EOC real questions. So I don't know for sure. As much as I would like to. Yeah? Yeah. So we're going to factor this trinomial completely, which basically means get those binomials. All right, we're doing the same thing. X squared gets broken down into x times x, and then we need to take these two numbers, draw a box times another box to get negative 45, and then a box plus a box equals positive 4. Now, here we need to get a negative product. What does that mean about the factors? Nope. One negative and one positive. So we're going to have quite a list of factor pairs here.
The water was yellow.
Gross.
It had dirt in it.
Gross.
It's nasty.
Which water fountain was that?
The blue one.
The one out there?
Yeah, that one's empty.
Oh, really? Okay.
You act like you're 25. Shut up.
Okay, let's think about factors of 45. 5 and 9. If 5 and 9 multiply together to get positive 45, then making one of them negative could get a negative 45, which means that it could also be possible to have a positive 5 and a negative 9, so basically making the other one negative. Both of these factor pairs would multiply together to get negative 45. Does that make sense? Really?
You said in the other problem that a negative number times a positive number gives you
a negative number, and that's what we need. So before we had a positive product, so we needed two negatives. Here we have a negative product, so we need one negative, one positive. Now, which of these pairs, now technically there are other factor pairs, like 3 and 15 would multiply to get positive 45, so one of them could be negative to get negative 45. You could also do 1 and 45. But I think Callie shouted this one out for a reason. She noticed that one of these pairs will get you a sum of positive 4. Which one? What? Negative 5 and positive 9. Why would we choose this pair? Because it's what? Small? Why would we choose this pair instead of this pair? Well, look what it has to get. It has to get. Right, so why is this pair the correct one and not this one? Yeah. Because if we add 5 plus negative 9, we'll get a negative 4. I'm sorry. I'm sorry. You want me to not ask you every single question? I keep asking because I can see that you're confused, so I'm trying to help you through it. But if you're getting overwhelmed, I'll back off a little bit. Me? Oh, we found the answer.
All of them.
Thank you. If I wanted to access an answer key, I could, but I'm just trying to do it step by step so everybody learns. It's kind of like what I do. Okay, so now we have a -5, -5, and a +9, so +9. And that would be the answer for that one. Negative what?
24.
Okay, so you need to multiply together to get -24, and you need to add to get what? +2. Okay, so what are some factor pairs? 12 and 2. Okay, I'm just gonna write 12 and 2. Now, one of these has to be negative. Okay, so when you add a -12 and a +2, do you get a +2 as your answer? You don't know? What's -12 plus 2? Do you not know because it's like a tough day, or do you just not know how to do that? Can you use a calculator then? Merry Christmas. Happy New Year. She's fine. Leave her alone. She's been quiet. She's not sleeping. She's just resting.
I'm playing with Jackie. You're playing on
You're right. So this isn't the factor pair. I just wrote it because you told me. So look, those don't work. Think of a different factor pair. That's why I make these boxes long. Emily, I make them long so I can write out a couple of different options. There are many different options to get 24. Don't even worry about the negative for now. Just give me factors of 24. 6 and 4. Give me another one. Very good. And if I wanted to, I could put 1 and 24, but that's not gonna do anything. Which of these factor pairs, don't worry about negative and positive for now. Which of these factor pairs, if I were to, actually, you do have to think of them as negative. Okay, what? 6 and 4. You can see that eventually the 8 and 3 will not get us a 2 in any way, shape, or form. But if we have a 6 and a 4, I know we have to add them, but one of them has to be negative to get to this negative product. So which would be negative, the 6 or the 4? Yes. The bigger one would have to be positive to get a positive sum. So it would be +6 and -4. I think the most challenging part of this for you is going to be the integers, and by integers I mean positives and negatives because I know you struggle with that. But just know that your calculator is going to be your best friend on this one. It might just take you a little bit longer because you'll have to punch in all of the options to see which one is present. On the homework?
Yeah, like explain it to me.
I don't think that would work out any better than her paying attention to me. I think she might get the answer quicker with you, but I don't think she's going to learn more. Are you on a different number than number 3, Emily?
Yeah, I'm
Okay.
See, Callie, she's explaining,
Okay,
how
you're
to
not
do numbers.
giving her answers at all? Okay, because I know kids tend to think they're helping and kind of give extra information. Just make sure you act like a teacher and you ask questions. You don't tell any answers, okay? It's so funny that this question is saying factor the trinomial or state that the trinomial is prime. It says check the factorization using FOIL multiplication, but nowhere in the lesson did it teach you FOIL. I taught that to you on my own. It's just so weird. Why would Sabbath say use FOIL if they only taught? What? I should. I'll page on it.
Are we the only school that uses it?
Oh no, I'm sure I'm supposed to.
You should do.
It's all over the country. Addie should. Okay, let's try this one. Now, I could do this one for you, but if you have different numbers, what's the point? You guys have your own number. So why don't you guys try to do number 4 on your own since you have different numbers than me. And then we'll reconvene on, try to do numbers 4 and 5 on your own. Actually 4, 5, and 6 on your own. And then 7 and 8 will require my help since this involves the lesson. So you're gonna do 4, 5, and 6 on your own. If you need help, you can ask me. I'm gonna look through this lesson. Yeah. What are your numbers? What do they have to, what's the product? 14. Okay, 14. Negative 9. Okay. Now again, your biggest challenge is going to be positive and negatives. Your best friend is going to be your calculator. I wish 7 and 2 is perfect. What signs do they need to be to get a positive product, but a negative sum? Are you able to try to think about that without the calculator or no? What? So when you did negative 7 times positive 2, what did you get?
No, I didn't.
Good. Okay. So, did you add them up and get a negative 9? Okay, did you multiply them to get a positive 14? It became negative? So then those didn't work. You need signs. You need signs for your 7 and your 2 that will multiply together to get a positive 14. What do your signs need to be for the 7 and the 2 to multiply together and get a positive number? Yes. Both.
Now, what letter do you Commercial break. Shush. Okay, now what are your factors in 1? 7 and 2. What? 7 times 2 is 27. 7 times 2 is 14. I think you might be a little bit off. No. Keep on my sentence. No, keep on my sentence. Okay, I'm working. 3. 7, 3. Okay. Can those be planned? Yeah. Are they both positive? Yeah. And then you have to add your 2 since they both have them right. Hey, you want to switch shoes? Abby, you're not switch shoes. No. Why? I'll bust through those shoes. I have.
We need to refocus. focus, because I have to do 2 examples that are not, you guys are not gonna be able to do. Are you ready to move on to that? Okay. All right, so we're gonna move on to this crazy thing. Keep in mind that you have not, except unless you're Ricky, Callie, or Abby, you have not learned the lesson for this specific example yet. So it's going to look weird. For now, I'm gonna give you guys the shortened version of how to solve this. When we have class, you're gonna learn the why behind it. Get it? Why? Wait, there's no why there. Never mind. Can't do the joke. Okay. So that.
Can I solve this one? Yeah. Because I don't know how to do it because Callie taught me.
Okay.
And this is actually kind of easy. Get up there. So, do you want me to do
Quiet back there.
Okay. Quiet us down. Since z is squared, you're gonna do the parentheses thing.
Mm-hmm.
Okay? And then, what are factors of 3? 42. Abby, be serious. Literally. 1. 31. Correct. Okay? You forgot the boxes.
It's okay. She doesn't need to do the boxes because we just need a product of 3. There is only one option. It's
Yeah.
1 and 3.
Okay.
And a sum of 4. 1 plus 3.
Yeah.
Yeah, we can do that part in our head.
Plus 3 plus 1. And we have one more thing we have to do. What do these 2 things have in common? Variables. So we're gonna put the C's like that. Now what we've been doing? What happened to the Z?
The Z's are there. See, totally correct. It just didn't explain why, which is fine. I'm also going to do a shortened version of this, but I'll probably give a little more information as to why this is happening. It looks strange because I can explain why this is correct. I can explain why this is correct by foiling it to show you if I multiply these binomials, I will end up with this, okay? What's happening is, with the other trinomials, we simply had a variable here, and then that same variable just here, right? But now we have an added variable. It has an exponent of 1, it's just a c in the middle, and then c squared at the end. How do we fit those into our binomials? It feels like, well, does the c need to go everywhere? It only needs to go at the end, and this is why. What's c times c? C squared. That, multiplying the last terms in terms of FOIL, multiplying the last terms, the 3c times the 1c, will get us 3 times 1 is 3, and c times c is c squared. That's one reason that we know that we need to include c's in the last terms. The other reason is because the O and the I in FOIL stand for multiplication of the outer terms, z times 1c, and multiplication of the inner terms, which are 3c times z. What's z times 1c? 1c, z, just put them in alphabetical order. What's 3c times z? 3cz. Notice how these terms are both cz terms. If we're foiling it, we would have to combine them. 1cz plus 3cz equals 4cz. That's why your middle term ends up with both the c and the z, because multiplying the outer and inner will give you that term. The shortcut, just as Emily said, is if you have that second variable and it's squared here and it's just hanging out in the middle, all you need are to break that c squared up into c and c here. That's the quick version. Do you have the same or is it different? Okay, do you want to do yours on the board? Okay, what does it say? C squared plus 7bc plus 6b squared. Okay, when we break that up, which variable is going to go here? C, very good. That's going to take care of that. I'm just going to cross it out so we're done with it, okay? Now I need, let's just take care of our numbers. I need a product of 6 and a sum of 7. Yes, yes, but here's some good news. They're both positive and super easy numbers. I want you to try to do it in your head, and I never do that. But I want to see you process it, okay? You are always allowed to do the boxes, but I also want you to process. I need a product of 6, where those two numbers will also add to 7. Think about that. It's like a little riddle. I need two numbers that will multiply to get 6, but will add to get 7. Very good. See, you knew that. That's why I wanted you to see for yourself that you are able to process that. So +1 plus 6. If this trinomial didn't have these b's and b squareds here, then this would be it. But we do need to have b in our binomials so that if we were to FOIL these and multiply them, we would end up getting the b's in the trinomial. They have to match. So where would the b's go? At the end. That's how simple it is. And then your answer, when you put in this answer, you do not have to show that one. It's an invisible one. And then the last problem is exactly the same concept. So if anybody needs help on their specific numbers, you just let me know. We have a couple of minutes left. How are you doing? Can I help things?
Pretty simple because you just add in the conclusion.
Good. Yeah? Yeah.